This is section 3, talking about the properties of water. Water is obviously one of the most essential compounds and molecules for life on Earth. We all depend on water, whether it's for sustenance or um, for us to be able to breed. Some animals live in water, and that's the only form that they use. And water comes in many forms. It can exist in the vapor form, in clouds. It can exist as precipitation and rain and snow and sleet and things like that. And obviously a majority of our water is stored in lakes and streams, and then underwater or underground in things called aquifers, which are giant underground reservoirs that contain a majority of our drinking water. And all of this water is recycled through the water cycle. If you look at the molecule of water itself, it is made of 2 hydrogen atoms and 1 oxygen atom. Now because hydrogen only has 1 little electron circling it, those electrons are kind of drawn to that oxygen. Oxygen has more electrons, and so that 1 little electron from hydrogen is going to get kind of sucked into the orbit of the oxygen atom. What that does is it causes this molecule to have an unbalanced charge. So the hydrogen becomes slightly positive because that electron has kind of moved away from it. And the oxygen is going to become more negative. That makes water sticky. What it means is it's going to behave more like a magnet, where the positives are going to stick to the negatives, and they become cohesive. So this kind of molecule is called a polar molecule, meaning part of it is negative and part of it is positive. Okay, so water is going to have its own bonding method, and it's called hydrogen bonding. Now, as far as bonds go, hydrogen bonds are pretty weak as compared to ionic or covalent bonds. Hydrogen bond is more like an attraction, more like a magnet. Okay, so the negative oxygen is going to get drawn to those positive hydrogens, and they're going to kind of stick together. Obviously, all it would take is a little heat to cause those bonds to break. This is why when we boil water, they can become a gas rather quickly. Those hydrogen bonds can just kind of fall apart. But when it's in the liquid form or even the solid form, they are stuck together. Okay, so this gives water several different properties. One of them is called cohesion, and that's when water is going to stick to other droplets of water. So for example, if you wax your car and it rains, the water is going to bead up into little tiny droplets. And that's because the water would rather stick to other water than to the wax on your car. So it's going to form droplets. This is also why rain comes in the form of droplets. They're going to want to stick together. The fact that water is polar also means that it will attract to any other polar surface. So glass, for example, is polar, and so the water is going to be attracted to it. So if you have plain glass with no coatings on it, the water is going to stick to it. And this is why sometimes, with our cars we use Rain-X. We put it on our windshield so that the water beads up and runs off on a rainy day instead of sticking to the glass. Capillary action means that it actually can move against gravity and go upward. So for example, in trees, as water is evaporating out of the leaves of trees, it can get sucked up from the roots and move upward against gravity. You sometimes see this in a straw. If you were to take a straw and put it in a cup and then you put your thumb over the straw, the water gets sucked up into the straw and it sticks to itself so that it can stay in there against gravity. And that is something that we use actually in lab quite a bit. You'll be doing a water lab in which you use capillary action to move water up filter paper, and then it will also draw pigments and whatever else you put in the water with it. It also causes water to have a high boiling temperature, which is 100 degrees Celsius. So it takes a little bit of effort to get water to boil, and that temperature of 100 degrees is where it becomes a vapor. Okay, we all know that water has 3 phases, right? The liquid water form, but then also the solid form in the vapor. And the solid form in ice and the gaseous form in vapor. When it's as ice, the water molecules are actually kind of stuck in a certain position. So there's actually air pockets in between those water molecules as they are kind of all sticking together, which is why ice is going to float. That means that it's less dense as a solid. There are many examples of where something is more dense as a solid, like with our metals. But water is unique in that it allows air pockets to get trapped in it when it freezes. Therefore, ice floats. Okay, we can also use water to make solutions. So basically a solution is when you dissolve something into something else. The thing that you're dissolving, let's say you're going to make some lemonade out of lemonade mix. The solute is the thing you're dissolving, so the lemonade mix. The solvent is going to be your water. You're going to mix the solute and solvent together to make a solution, and you make lemonade. So you make something new out of the two materials. Okay, water is going to naturally break down into an oxygen and hydrogen, which is called a hydroxide, and a hydrogen atom. And so in water, it's got an equal amount of both of those, right? So it's a neutral solution, which is at a pH of 7. There are substances that have more of the hydrogen and less of the hydroxide, which makes it an acid. So things like your stomach acid, battery acid, vinegar, things like that are all acids because they're going to have more of those H's on their molecules. When there's more of the OH's, that makes it a base. So something like ammonia is going to have OH in its chemical formula, and that makes it basic, so above 7. So here you can see kind of the pH scale. pH 7 is going to be pure water. As you go up the scale, that is stronger and stronger bases. And bases are going to neutralize acids. So let's say you're eating spicy food that's it's got vinegar in it and other acids in it. You're going to want to have something basic to kind of balance it out. And so that's why we sometimes drink milk with our spicy foods because it neutralizes the acid. You could tell an acid because it's usually sour, something like orange juice, lemon juice, those are all acids. And bases taste really bitter. Both of them are dangerous. So if you get down to a pH of 1 and 2, you can burn your skin. If you get up to pH 13, 14, those are also very dangerous for your skin. So sometimes in a lab, we might have baking soda on hand so that if we spill an acid, we just put baking soda on it and that will neutralize it before we clean it up so that it's safer to clean. And this is the end of section 3.